Okay, hello everyone. Great to be here again. I was actually, I think 5 years ago, was probably not here, but last time I was in Toronto was 5 years ago. I moved to Singapore 3 years ago. Previously I was in New Jersey. It was a lot easier to get here, but now it's a 20 hours flight. So, but happy to be here again finally, and thanks everyone for coming. So today, I'm going to be talking about Vue, Vite, and the future of JS tooling. So, let's get started. So first of all, it's 2024, and Vue is now 10 years old. Sounds like a very long time in the JavaScript world, considering that people say that there's a new framework coming out every day. So for Vue to be around for this a long time, I guess that's really a thing to celebrate. So let's take a look at the brief timeline of how Vue sort of grew from a personal side project to what it is today. Right? The first release with the name Vue.js was actually back in 2013 when I was still working at Google, and this was just really a side project that I played around with in my spare time. I came up with the name Vue when I was looking for a name for the library, and I think, okay, this is a Vue library. It sits on the Vue layer, right? But the name, the English word obviously was already taken on NPM, so I looked it up in the dictionary, put it in Google Translate, tried different languages, found that the French translation was only 3 letters, and it was available on NPM, so Vue it is. So that's how the name came out to be. And the first public announcement was in February 2014 when I first posted about Vue on Hacker News. So it got a few hundred stars in the first few weeks, and I was really excited. And in 2015, we finally got to 1.0. So Vue 1.0, how many of you have actually used Vue 1 in the past? Okay, quite a few. Very cool. So Vue 1 mostly was about just finalizing the template syntax. So there was actually a pretty lengthy discussion. If you've used Vue before 1 and after 1, you notice that a lot of template syntax kind of changed. But luckily, Vue 1 essentially established the directive syntax, which today we still use. And Vue 2 came out in October 2016. 2016 was also the year I started working on Vue full-time. So in February 2016, I left a job at Meteor, which was a startup that I was working for, and decided to just give it a shot because I really wanted to work on Vue more. Had no real plans on how I would make money with it, aside from hoping there would be sponsorships. Turns out things worked decently well, so I was able to work on it more and more, and eventually it stabilized as actually a full-time thing. So in 2018, we started thinking about the idea of Vue 3. There are multiple reasons for doing the new major version. One of them mostly is about raising the language baseline so we can use new language features in ES 2015. Also to rewrite the whole thing in TypeScript so we can get better types, better TypeScript support. Vue 3 also came around with the introduction of the new composition API. Well, nowadays it's no longer new, but back then it was kind of a big discussion about whether it's justified or whether people really want it. So this whole, Vue 3 was essentially multiple things combined in a single release, and along with many small breaking changes. So the process really dragged on, and I would say it was probably the most challenging period of the whole Vue development, during the whole history of Vue development for me personally. So in September 2020, we finally released Vue 3 Core, but that was a soft launch because as the framework grew in scope, we had more and more things that we need to cover in addition to Vue Core. So we need to also handle the DevTools, language IDE support, the build toolchain. We had to get router and state management, and everything, documentation needs to be all updated accordingly. So that took even longer. And there was also this big transition period where the ecosystem was trying to catch up with V3 because a lot of the libraries, especially UI components, they couldn't migrate directly over to Vue 3, so a lot of them had to be kind of rewritten. So in 2022, we finally made the switch to Vue 3, and that kind of marked a period where, okay, Vue 3 is stable, everything is ready, ecosystem is catching up and maturing around Vue 3, and finally in 2023, end of 2023, we basically announced the end of life for Vue 2. So, well, now we're mostly focused on improving Vue 3. So that is a pretty solid foundation to build upon into the future. And our plan is to essentially never do this kind of Vue 2 to Vue 3 transition again. If we ever ship major versions of Vue in the future, it's going to be more like Angular major versions where it's just small changes, auto-migratable, and most of the major version upgrades should be easily done in a day or two. So, looking back at the history, right? So 1.0, 2.0, 3.0, each of them are, kind of came with major changes. And I think the reason Vue is able to stay relevant over a 10-year period and still growing is because we are really open to absorbing new ideas. We're open to reinventing what Vue stands for. We're open to thinking about what are the changes needed to make developers' lives better, right? So in Vue 1, we used what we call DOM-based templating. So it was coupled to the browser. So Vue 1 only runs in the browser. You cannot run Vue 1 for server-side rendering. It just didn't support it. So in Vue 2, we started supporting server-side rendering with introduction of virtual DOM, so the whole application can now run in Node.js without a DOM and can be rendered to strings. And in Vue 3, we improved it further by introducing composition API because the user base started to build bigger and bigger applications. And the increase in the scale and complexity of the apps people are building with Vue requires newer APIs, better TypeScript support to support that kind of scale. Raising the language support baseline to ES 2015 also allows us to use more native language features like proxies to improve the developer experience. We fixed some of the notable reactivity caveats that's present in Vue 2, which you no longer need to think about in Vue 3. And it also came with a much more powerful compiler compared to Vue 2, where we're able to do more static analysis of your templates, essentially move more work to the build time instead of runtime. So the compiler is able to infer a lot more information from your templates and make your runtime go faster. And this trend also continues in the work that's going on right now. Okay, so let's take a look at Vue's current and future. Some stats. So Vue today in numbers, I think we're closing in on almost 10,000 commits across Vue 2 and Vue 3 repo. We've made over 500 releases in the past 10 years, currently at 2.3 million plus users worldwide. This is the weekly active users based on our Chrome extension, the DevTools extension. It's probably not the most accurate, but I think it's a good proxy for the people actually using Vue to some extent. 2 repos combined with 250,000 plus Git stars. If we count in every repo under the Vue organization, it's probably much higher. And we're now at 5.5 million weekly NPM downloads and 1 billion plus monthly CDN requests on JS Deliver. So over the past year, from November 2023 to November 2024, essentially this month, we still saw a 37% year-over-year growth. And this is based on a already pretty substantial user base with I think 17 million monthly downloads last year. So considering the amount of saturation major frameworks already have in the web development market, I think this is a pretty significant growth considered for a framework that's 10 years old. And more notably, Vue 3, the percentage of Vue 3 among all the applications also grew. So if we look at this graph, this is looking at the downloads, monthly downloads of the @Vue/runtime core package, which is an internal dependency of Vue 3. So only Vue 3 relies on this package, so you can use it as sort of a proxy for Vue 3 downloads. It grew from 8.7 million. I think this is weekly numbers. This is monthly numbers, yeah. So November 2024 is now like 15.6. So over the past year, it's like 78% increase. So you can see the number of apps being built with Vue 3 is growing at a much faster pace. And Vue 3 now constitutes more than 66% of total NPM usage, and the percentage is increasing as we speak. So as I said, Vue 3 intends to be really stable, but being stable also is not mutually exclusive from continuing to improve the development experience. So some of the major things we did after Vue 3, 3.2 we introduced script setup, which significantly increased the development experience when using composition API in single file components. And in 3.3, we made this development paradigm even better with TypeScript. So you can write your props types once, and Vue will infer the runtime definition for it automatically for you. In 3.4, we did a full parser rewrite, which makes the Vue parser 2 times faster than before without any breaking changes. So this is also a recurring theme of what we're doing with Vue right now is we want to do more kind of work that just makes things more efficient, makes things faster without requiring the user to do code changes or migrations or refactors, right? The value of being a stable framework is that we can make things faster without you having to do any work, just by upgrading. Right? So reactivity refactoring 3.4 also made the reactivity system a lot more efficient, addressing some long-standing issues in computed re-invalidation. So previously in Vue, computed actually runs a bit more than necessary. So 3.4 used a different algorithm to essentially make that make computed run as efficiently as possible. So avoid unnecessary duplicated invocations. 3.4 also stabilized defined model, so makes it easier for you to create your custom input components. And more quality of life small improvements. So the latest release, Vue 3.5, shipped even more reactivity efficiency improvements. So pull request 10407 provided a 56% less memory usage compared to 3.4. And we also improved the reactivity tracking cost when we're dealing with large reactive arrays, in some cases up to 10 times more efficient. So we also stabilized reactive props destructure. So this is an interesting feature which allows you to destructure your defined props call, and the destructured bindings will remain reactive. And use template ref gives you a more ergonomic way of using template refs. Previously, the way of getting a ref from your template is by just declaring a ref variable with the same name. It actually was confusing to some extent because there are some edge cases where it just behaved differently between development and production. And we always felt that was kind of problematic. So use template ref now allows you to essentially use the same string as the ref ID, both in your JavaScript and in your template. And more importantly, it comes with built-in IDE support. So you no longer need to manually annotate the types for your template refs when you use template ref. The IDE will be able to automatically infer the type of the ref based on where it is used in the template. For example, if you use the ref on a component, the IDE support will automatically infer the component's type on the return value of the use template ref call. So that actually makes things a lot easier to get correct types with template refs. And there is a bunch of SSR improvements, for example, built-in lazy hydration and use ID. So these are the things Nuxt users have been asking for a very long time, and now they're built in, and Nuxt is able to either use the native implementation instead of the custom one, or they can build on top of built-in lazy hydration for higher level syntax sugar to make your SSR apps boot up more efficiently. And then there's a large chunk of define custom element improvements. So if you are using Vue, in case you don't know, you can actually use this to build interoperable native web custom elements, but using the Vue syntax. So you can take a single file component, a Vue SFC, import it, and then wrap it with define custom element, and it just becomes a native custom element that you can use anywhere. You can use it in React apps or Angular apps or just in vanilla.js. So previously it had a bunch of issues that has been long-standing, but we fixed most of them in 3.5. So this is now much more robust. And if you haven't tried this, and if you have the use case where you say, I want to build with Vue, but I also want the component to be able to be consumed by a downstream user who doesn't necessarily use Vue, this is the perfect use case for it. So alongside the way, we did invest a lot into the surrounding tooling support. So for example, Johnson, who was the original author of Volar, which is now the Vue official VS Code extension, has been spending a lot of time trying to battle with finding the ideal way to do single file component support in VS Code. So eventually this led to him extracting the underlying logic of the Vue IDE extension into a standalone project called Volar. And so Volar now stands for the framework agnostic base, which is essentially a toolkit for supporting embedded languages in custom file formats in IDEs. So for example, Vue single file components, we do write TypeScript inside single file components. We also write CSS inside single file components. So the challenge here is VS Code doesn't understand this custom format. So the IDE, our extension essentially needs to teach VS Code to say, this part should be treated as TypeScript, so we need to start a TypeScript language server for it, and we get the diagnostics, and we need to map it into the original positions in the original file. Most of these are actually not specific to Vue, because there are other file formats that need to do this as well. For example, in MDX, which is a format where you can write MD markdown files, but with JSX embedded inside of it. And then there are frameworks like Astral, which also has its custom format and embeds TypeScript inside of it. A lot of these file formats can leverage the same underlying architecture for IDE support. So Volar essentially is now a common base for this kind of support. And we're seeing people building, there are, for example, Angular users experimenting with single file components for Angular and using Volar for the IDE support. Ember is also trying to do this kind of stuff, also relying on Volar for IDE support. So Johnson has been working a lot on that, and most notably in Volar 2.0, we no longer need to manually enable takeover mode. So the original need for takeover mode was because in a typical Vue application, if you use TypeScript, right, you will have normal TypeScript files, and then you will have TypeScript embedded inside Vue files. Up to Volar 2.0, we actually had to start two separate TypeScript language servers, one for handling in-component code, one for handling normal TypeScript. And that was wasteful because it essentially doubles the memory cost, and we have to kind of do the plumbing between the two language servers. So takeover mode was kind of experimental, in which it allows us to use one language server for handling both, but it required you to opt into it because it required you to disable the original default language TypeScript language server in VS Code. Now, hybrid mode kind of just like does this seamlessly now. So it avoids the double language server overhead without you having to do anything. And recently, we also stabilized the new version of the DevTools extension in Chrome. So this is a whole new version of Vue DevTools, now finally written in Vue 3 itself. We've in fact been using the original code base of Vue DevTools v6, which was originally written in Vue 2, designed for Vue 2, and we added support for Vue 3, but the whole DevTools itself was actually still in Vue 2. So this new version is now written in Vue 3, and is much more performant, less crashing, less memory usage. So if you haven't, I think the upgrade is automatic, so if you've been using the stable channel, it should now just be the default. So definitely check it out. And we're continuing to work on Vapor mode, which is a new compilation strategy for Vue components. We'll dig a bit into Vapor mode a bit later, but on a high level, Vapor mode allows you to take the same single file component without changing anything, pretty much, right? So right now, it supports a subset of the feature set. So it's like 80% of the features of what you can do with Vue. The main things that's currently not supported yet are async components and some of the built-in components like transition, keep alive, or suspense. But other than that, most of the built-in directives and normal component usage is all supported. So API, as long as they're supported, they work exactly the same, but they're compiled into more efficient output, and the performance is actually now on par with Svelte. And there are still tons of things we can still optimize, and still there are more performance opportunities that we can sort of unlock. And feature-wise, it can actually now run the default theme for VitePress. So we're using VitePress as kind of a big dogfooding opportunity because we fully control it. And in the near future, there will be a version of VitePress that is underlying the bundler will be powered by Rolldown, which is a Rust bundler I'll talk about in a bit, and with the runtime layer, the Vue part running in Vapor mode. VitePress will be probably the most cutting-edge tooling that you can try to experience the latest advancements in this ecosystem. So the next step from Vapor is more perf tooling, and we need to support SSR hydration, async components, and built-in components. So these are the major things left. But Vapor mode is already somewhat usable, so we do plan to introduce Vapor as an experimental feature in 3.6. And another thing that's important thing coming in 3.6 is Johnson actually did another big refactor of the reactivity system. So this time, he started with a project called Alien Signals, in which he benchmarked it against all the major reactivity/signal implementations out there, and basically came up with the fastest one, bar none. And then he ported the core findings of the optimizations back into Vue core. So now it's in this PR 12349. We are planning to merge this into the development minor branch very soon. Shows another minus 14% in memory usage and massive improvements compared to 3.5, which already had a big jump compared to 3.4 across the board. In some cases, up to like 3x more efficient. And this is now literally one of the fastest reactivity, actually literally the fastest reactivity implementation across all the ones that we have surveyed. So this would also help us on, in the JS framework benchmark, probably, to some extent. But most importantly, we are continuously trying to make Vue internals faster without requiring to rewrite anything. So this PR right now passes Vue's own tests and passes all Vue ecosystem tests. So stability-wise, I think it should actually just work in your application today. So, but obviously, this is still a major refactor, so it will go through the normal alpha-beta cycle of the 3.6 so that people have an opportunity to test run it. 3.6 will also introduce Vapor as an experimental feature, which means you'll be able to upgrade to 3.6, and then you can take a component, change your script setup tag to script Vapor, and that component will opt into Vapor mode. We also plan to stabilize suspense in 3.6, which you've probably gotten tired of the experimental warning at this point, but long overdue, but we'll do it. in 3.6. So the estimated timing for 3.6 will be sometime in Q1 2025. Okay, so that's it for Vue. And now let's talk a bit about Vite. So I assume most of you nowadays are developing Vue applications with Vite. And Vite itself has seen pretty amazing growth over the past few years. Well, it was created in 2020, but over a little bit over 4 years, it has quickly become a shared infrastructure for not just Vue, but multiple other frameworks. Right? If you think about the wider front-end ecosystem or wider JavaScript application ecosystem, we'll see a list of all the things that's using Vite nowadays. But the growth over the past year, over 100%, so over double the download count compared to the same time last year. And in the State of JS 2023 survey, Vite and Vitest essentially got probably all the highest recognitions that you can get. So number 1 most adopted, number 1 highest retention, number 2 highest interest for Vite, and also the most loved library overall. Vitest was the number 3 most adopted, number 2 highest retention, the number 1 highest interest. And by the way, State of JS 2024 is now open. So I would appreciate anyone who's using Vue or Vite to participate and make your preference respected in the survey, reflected in the survey. So Vite now has a vast ecosystem. So first of all, there are front-end frameworks defaulting to Vite for the tooling. So Vue, of course. In fact, I think most new React single-page applications are now built with Vite. Svelte, Quick, even Angular, since version 16, is using Vite as their dev server. So, and then there are these meta frameworks, full-stack meta frameworks built on top of Vite. So there's Astro, SvelteKit, Solid Start, Quick, and then there's Remix, Analog, Marco. Then we have official integration with Laravel, and we have a community integration with Rails, so you can use them in these other popular backend frameworks easily. Interestingly, if we just ignore Next.js for a minute, then we'll notice that all the other frameworks are now built on top of Vite. So Vite has essentially become the shared infrastructure layer for the next generation of web apps. And that's a big responsibility, right? Because deep down, I've always known that Vite isn't perfect. When I created Vite, again, as a side project, when I was working on Vue 3, I was mostly trying to build a simple dev server. And I want things to, just get things to work as fast as possible. So even though we did a major refactor in Vite 2, there are some underlying things that I always wanted to fix, right? So let's talk about that. Today's Vite still relies on multiple different dependencies with overlapping duties. Right? So if you install Vite today, you'll notice that in your dependency tree, there's also esbuild, there's rollup. There's no SWC by default, but a lot of React users, when they use Vite, they still rely on SWC because they need to compile JSX, and with React Hot Module replacement, and Babel is really slow, so there is a plugin that allows them to use SWC for that. So, so if someone builds a React app today with Vite, they're not just using Vite. They're using all these things together. And that's still not good, because the problem with this current architecture is that we kind of have to use these different things together, because each of them does something that we need, but also not entirely satisfies the requirements. So for example, esbuild is used in Vite for dependency pre-bundling. It's used for transforming TypeScript. It's used for minification as the default minifier. But we cannot use esbuild as a production bundler, because esbuild's limited chunk split is very, very limited. There's almost no customization that you can do with it. its tree shaking is also not as good as rollups. And its plugin system is somewhat lacks flexibility in a way, right? The way that ESBuild works also is that its internals is very hard for other people to essentially contribute to, mostly because it's trying to get the best performance possible. So ESBuild's architecture essentially overlays different concerns like minification, transform, and all these different tasks in as few AST passes as possible. So when it parses the JavaScript code into an AST and doing the traversal, it will do multiple different things in the same pass. And this makes it quite difficult for other people to add new major features on top of ESBuild, right? So if you're asking like, why don't we like fork ESBuild or contribute major features to ESBuild, right? That's kind of the reason, right? People have tried and it's hard. Rollup is what we use for production build today, right? So if you use Vite to bundle for production, you're using Rollup. But Rollup is written in JavaScript, and compared to something like ESBuild, it is slow. It can be orders of magnitude slower. Right? Rust and Go just produces much better performance in general. But Rollup has a lot of nice things that we really need. For example, it has a great plugin ecosystem. Its plugin interface is very simple and intuitive to use. People can quickly whip up a custom plugin to solve their own problems. There's a great ecosystem. It has also decent level of chunk control. So it's better than ESBuild and is satisfactory for a lot of applications. But its asset control and chunking control is also something that can be improved compared to Webpack. But people also kind of want to avoid Webpack because configuring it correctly is very difficult. Right? So a lot of, we wish we had this from this other tool, but then for some reason we need to stick with this tool kind of situation. And finally, for SWC, it has great performance. It has a great set of features. It can do transforms. It can do minification very well, but it technically comes with a bundler, but it's not usable. And it has really heavy binary. SWC, if you install it, it's 37 megabytes, I believe. That's like heavier than Vite plus ESBuild plus Rollup, and twice as heavy as these other three combined. So it's quite a big dependency. So relying on these different things, if they just work, it's great, but in addition to the redundancy, there's also compatibility issues. For example, during development right now, Vite treats your source code as native ES modules and load them through native browser ESM. But for dependencies, we pre-bundle them with ESBuild. So this introduces some subtle problems when you have mixed ESM and CommonJS code in your dependencies, because now they need to be there is something called module interop that we need to merge these different module formats into the same ESM bundle. And ESBuild can do that. Rollup also does that, but Rollup does that slightly differently from ESBuild. And during development, your dependencies are handled by ESBuild, and during production, your whole module graph is handled by Rollup. And both of them kind of treats ESM and CJS interop slightly differently. And although for most correctly written modules, this will just work, unfortunately in the ecosystem, there are often dependencies that are written in weird ways. For example, people would compile ESM source code to CJS, then masquerade as fake ESM. And it'll often cause really weird issues. And sometimes these issues can only be discovered after you deploy to production. So that is not nice, and we do hope we can fix that. And when you have all these different tools, right, the unfortunate thing is there is a lot of repeated overhead because each of them comes with their own parser implementation, their own AST representation, and different code generation pipelines. So we cannot reuse work between these tools. Let's say you have a TypeScript file in your application, During development, it needs to be transformed by ESBuild, and that is a whole parse, transform, and regenerate to strings. And we also need to first pass the source code from JavaScript to the Go side in ESBuild, and then ESBuild will send it back to JavaScript. So in Rollup has its own parser and has its own transform phase, its own code generation phase. And SWC also has its own. So in the worst case scenario, your same piece of code might be parsed by 3 to 4 different parsers, transformed by them, converted back to string, passed between JavaScript, Node.js main thread, to the Go thread, to the Rust thread, back and forth multiple times. Right? So there's a lot of overhead just because we're using different tools for different tasks. So it'd be really nice if we can eliminate all these overhead with one unified toolchain, right? And on top of that, Vite's current unbundled ESM approach to dev server, it's great when you have small to medium scale applications, right? It probably works fine for most of you, but as we start to get more and more users, right, there are big companies building really, really large internal apps with like thousands of modules, thousands of source code modules that needs to be loaded over unbundled ESM. So when you're unbundled, which means if you have 5,000 source modules, that's 5,000 HTTP requests. And the browser kind of just starts struggling with handling that amount of requests in parallel. And on local dev servers, this can often result in opening. The dev server starts really, really fast, but you open the page and you have to wait a few seconds for all the modules to load. And this is also something we do want to eventually fix. So we thought about all these problems, and one of the conclusions we came up with is we need to unify the bundler that's being used in Vite, right? So we started working on our own bundler called Rolldown. It's written in Rust. It's inspired by Rollup. It will have a similar feature set with ESBuild. And it will we try to basically build the best of all these different worlds and try to essentially, for example, we want to have the all-in-one capability of ESBuild. We want to have the support the plugin ecosystem Rollup. We also want to have the advanced features that's only available in Webpack, for example, better control over how to split your chunks, and maybe module federation in the future. Right? So, but as we work on the bundler, we noticed another problem because once you dig beneath the bundler, there's also more questions to be answered. Like, what parser do you use? What transform do you use, right? Do we want to implement everything ourselves from scratch? Right? So we noticed that the challenge Vite is facing, right, like all these different tasks need to be handled by different dependencies, is a reflection of the JavaScript ecosystem at large, because we are so used to using one specific tool for one specific problem, and our dependency tree, as a result, is a collection of hundreds of NPM dependencies. And also because every project kind of have to go through this tooling selection process again, they more or less end up with something that looks similar but also different. Right? So if you are in a big company and you have multiple teams working on their own front-end projects, and you look into the dependencies of these projects, they probably all use the same set of things, but then on different versions, and one of them will be using Jest, one of them will be using Vitest, some of them might still be stuck on Jasmine or Mocha. So this problem is widespread in the JavaScript ecosystem. And it would be really nice if we can eliminate this inconsistency and inefficiency by providing a unified toolchain that is able to essentially use the same parser, same AST, the same set of underlying infrastructure to handle all these different tasks, right? So that's a pretty ambitious goal. And that is why, when we have the idea, when you realize, okay, like this is not something we can just do by having a bunch of volunteer contributors work on this together in their spare time. It's not just going to happen that way. So that's why I started the company called VoidZero to essentially get together a team of dedicated engineers to work on a set of lower-level tools for the JavaScript ecosystem so that we can have a consistent and efficient foundation to build higher level things on. Okay, so here is the big picture of what we envision, to essentially bring into reality in the next few years. So the first thing is at the very bottom, the toolchain is, this whole language toolchain is powered by the Oxc project. The Oxc project is led by Bo-Shen Chen, and he was previously working at ByteDance Web Infra when he started working on the Oxc project. And it came out of his experience working on RSPack and dealing with SWC, and he was also learning Rust, and he found out quite a bit of architectural problems that he felt that could be better addressed compared to SWC. So Oxc also started out as his personal experiment of digging into Rust performance. How can we write the most performant Rust parser possible? And that later on developed into a whole set of tools, including the linter, the transformer. So some of these are kind of planned. We have the infrastructure for them, but they're not fully completed yet. For example, the formatter and minifier, they all have prototypes that we can make them work, but obviously there's a lot of features that we need to complete for them. But the linter and formatter are more or less feature complete. There's also a fully Node.js compliant resolver. There is a fully ECMA 262 compliant parser, probably the most spec compliant one outside of browser JavaScript engines. And then there's a semantic analysis API that you can use alongside the parser to do advanced language manipulation. So all of this together forms as the foundation for the higher level tools that we want to build, and that powers Rolldown. So Rolldown is now fully supported by Oxc, and the scope of Rolldown, like I said, it will be rollup compatible as much as possible. It will have a similar scope to ESBuild, so it will essentially, it's a bundler, but it can do transform, minification, all in the same thing. Or it has built-in TypeScript transforms, built-in JSX transforms, built-in target lowering transforms, built-in minification, built-in node resolve, built-in ESM and CJS interop, all of these without a need for plugins. And then it will be powering Vite. So in Vite, we will replace ESBuild and Rollup with Rolldown. So you get better dev and prod consistency, you get better build performance, and you have fewer dependencies and a lighter binary size. And Vite also powers vtest. So by extension, vtest will also benefit greatly from Rolldown. And finally, Vite and vtest will be the infrastructure layer that's powering all these higher level frameworks that are building on top of them. So I want to talk a bit about the vision for this toolchain. There are a few characteristics that I think are really important. The first is it needs to be unified, right? All the different tasks involved in the process of turning your source code into production artifacts should be performed by the same set of tools on the same AST with the same consistent rules for configuration, right? They should use the same source for configuration. They should use the same module interop behavior. They should have the same module resolution behavior. So how many times have you run into bugs because, for example, your test runner and your bundler doesn't resolve things the same way, or they just doesn't treat the same module the same way, right? Historically, this has been always confusing for JavaScript developers. And by using a set of unified tools, we can essentially move this category of bugs off the plate for us altogether. It needs to be high performance. So there is an interesting balance or a line to be drawn on what should be implemented in compiled to native languages like Rust and what should remain in JavaScript. So my opinion on that is there are many well-defined tasks. By well-defined, I mean slowly moving targets. For example, the language specification for JavaScript, it's quite stable. Maybe every year we will have a few additional features, and most of them don't really involve syntax level changes, right? So the parser, once you've written it, doesn't require very heavy ongoing maintenance because the language is not changing that fast. So the parser is a really good candidate to be written in Rust instead of in JavaScript, because the performance benefits is just huge. Right? So the whole toolchain that we're building in Rust is essentially trying to squeeze out as much performance as possible at every opportunity. Right? So given JavaScript's scale today, performance improvements in our tooling, right, is a huge leverage, like faster feedback loops, faster CI build minutes, right? So allows you to just innovate faster, experiment faster, and ship faster, and ultimately saves money for your business. And the toolchain itself also needs to be composable, right? So ESBuild, for example, is a great piece of software. The unfortunate fact is ESBuild itself internally is very intertwined. Every piece inside ESBuild is kind of tightly coupled with one another. So you can't just take its parser out of ESBuild and use it as a parser standalone. Right? You cannot just leverage its resolver. In a lot of ways, in Vite, for example, sometimes we need to do things like what we call dependency scanning. For when we pre-bundle dependencies, we want to kind of do a precursor pass to scan the code base and look for possible dependencies. Right? We kind of have to hack around that by using ESBuild. We do a kind of like a fake build to force ESBuild to walk through the module graph, but without actually like outputting anything. Right? So that's the problem with, you know, it's integrated, but it's a black box. So in a lot of cases, we do want to leverage part of the toolkit, but we kind of have to kind of hack around it. So we want to build Oxc slightly differently, right? Every part of the Oxc toolchain, for example, the parser, the resolver, the transformer, they're all exposed as separate Rust crates. So if you're building your own toolchain in Rust, you can leverage these parts by only importing some of them. They're also available as npm packages. For example, today, you can do npm install oxc-parser and use it as a kind of a drop-in replacement over Babel parser. And you can also download Oxc resolver, Oxc transformer, and use it in certain cases where you only need one part of the toolchain. And finally, we want the toolchain to be runtime agnostic, which means the Rust parts of our toolchain are not written assuming that it only runs in a specific environment. So you have probably heard about JavaScript runtimes like Dino or Bun, which also ships with a ton of tooling themselves. The problem with the tooling that comes with runtimes is they are essentially designed to attract you to use the runtime and trying to vendor lock you into that runtime. And for us, I personally don't think that having a comprehensive set of tooling coupled to a specific runtime is good for JavaScript overall, right? If we are writing JavaScript, no matter where you want your code to run, no matter which runtime you're developing on, you should have access to the same set of consistent tooling, right? You don't want to say when you decide to switch from one runtime to another, now you have to opt into a whole new set of tooling. You want to be able to just continue using the same set of tooling you're familiar with. Lucky enough, most of these runtimes are Node.js compatible, which means if you use Vite, you can run it with Bun, run it with Dino, run it with Node.js. It all work the same. Okay, so we've talked a lot about what we want to build, but what we have actually built, and how long will it take for us to actually get there, right? Oxc right now has there are many parts in Oxc, but what we've completed so far is the parser, the linter, the resolver, and the transformer will be done probably in the next month or so. Right? Transformer is almost done. And then minifier and the formatter are in prototyping stage. The minifier is already usable, but we haven't fully maxed out the compression ratio yet. So there are a lot of advanced things we will need to work on after the transformer. The formatter is also usable, but again, it's a lot of work because essentially the formatter, what we need to do with the formatter is just try to get it as compatible with Prettier as possible. And in a way, Biome already does that, so we're not really in a hurry to just implement formatter for completion's sake. Right? You can use Biome along with Oxc in the meanwhile, but we will eventually get the formatter done, so you can use just one tool for all these tasks. So in terms of performance, as I said, performance is probably the core value of this whole thing. Oxc is the fastest parser that we know of that can be used standalone. It's 3 times faster than SWC, both of which are written in Rust, right? So as I said, when Boschum started Oxc, he learned a lot about the problems of SWC because he worked with it extensively in RSpec. It's also 5 times faster than Biomes parser, which is also written in Rust. Right? So even both written in compiled to native languages, there could still be big performance differences. It's also the fastest linter. So if you use ESLint, ESLint, unfortunately, is pretty slow because its plugin architecture is a bit too flexible, and JavaScript is single-threaded. So Oxlint is able to leverage the full number of cores on your CPUs, so which means the more powerful your machine is, the faster the performance will be. So in the case where Shopify adopted Oxlint over ESLint, previously their ESLint runs actually took 8 minutes to link their code base, which is huge. It's like 60,000 lines of code. But with Oxlint, they trimmed it down to 8 seconds. So that's like 60 times faster. So the fastest resolver, it's a Rust-based resolver, 28x faster than Webpack. I think Parso just recently refactored their resolver. In the cached case, it's now slightly faster than the Oxc resolver, but essentially we're kind of like learning from one another because Parso refactored it by learning how Oxc resolver is doing the caching, so we can now learn a bit back from them and also make Oxc resolver faster. And it's also the fastest transformer, right? So compared with other Rust-based transforms, we're 4 to 6 times faster than SWC and 40 to 70 times faster than Babel. It's also, more memory efficient. So compared to SWC core, we use 24% less memory and 70% less memory than Babel. And more notably, this is something a lot of people overlook, but I personally care a lot about how big my node modules directory is. So we care a lot about all the binary size of the Rust tooling that we ship. So Oxc transform, when you install it from NPM, the binary for Mac OS is less than 2 megabytes, whereas SWC is 37.5. And interestingly, even if you download Babel, which is pure JS, it's 21 megabytes on your disk. Like Babel is actually huge. It's a lot of small JavaScript files, right? So the binary version actually is a lot more disk efficient as well. Okay, now for Rolldown, the progress. Rolldown is actually, this is actually a little bit outdated because we finished the general purpose bundler step. And so Rolldown is already quite usable as a standalone library bundler. You might have seen that we have successfully used Rolldown to replace Rollup to bundle Vue itself. So the whole build process, so there are a few things we still need to tweak in Rolldown, mostly because we're waiting on a few transform features to complete in Oxc. But in the Rolldown branch of Vue core, the whole build process to bundle all the disk files for the 11 packages, plus generating the DTS, plus bundling the DTS, the whole process took around 1 second. Whereas there will be a case study, but Rolldown is already pretty capable. We're also in the process of bundling Vite itself with Rolldown. So we're doing a lot of this kind of inception and dog fooding to test the robustness of our implementations. So general purpose bundler is actually already done. So now we are mostly focusing on Vite integration and 1.0 beta. We're pushing for 1.0 beta, and it'll probably be out before Christmas. So for 1.0 beta, the main thing is more stability and robustness. We are pulling in the test cases from both ESBuild and Rollup, running all these conformance tests. For example, ESBuild has a pretty good test suite around module interop. We're trying to pass all of them. More performance tuning and documentation, DX polishes before we release it as beta. But if you're interested, you can play with it now. It's pretty usable. And for Vite integration, There is a version of Vite that's already running on Rolldown. It can already build a lot of basic applications. Right now, the tests, we passed most of the tests for build. There's actually one test that's not passing, mostly because it's for the legacy build. For the legacy plugin, which we don't really support in Oxc, because we're not going to do the down to ES5 transpilation. But other than that, we actually pass all the tests for development, and we, in fact, also are close to passing all the tests for the build as well. So this is also a bit outdated, but we're also already able to run VitePress on top of this version of Vite to build the documentation of Rolldown itself. So a lot of internal dogfooding, and we're looking, it's very promising. Performance is pretty much slightly faster than ES build, and but with a lot more configurability, with better plugin compatibility, and also more advanced features, most notably the better chunking control. So this is performance. This is the benchmark for bundling 19,000 modules with 19,000 modules, 10,000 React JSX components, and 9,000 dependency files. So that's probably, 1 million lines of code. And Rolldown can bundle that in 0.6 seconds. And we're not even including any JS bundlers here. All these listed options are either written in Go or in Rust. Rolldown Vite itself is the version of Vite that's running on Rolldown. So it's slower than raw Rolldown because there is the overhead of some internal JS plugins that we run on top of Rolldown for behavior compatibility. But this data is also now kind of outdated because most of these overhead comes from the JS resolver. And in the past few weeks, we actually successfully ported most of the JS resolver logic to the Rust side as well. So now, Rolldown Power Vite actually builds as fast as raw Rolldown itself. And all the other ones, we're at least twice as fast for the other cases. So, but this benchmark is kind of dependent on the machine you're running it on. So the more number of cores you have, the better performance Rolldown will have as well, because of the maximum parallelization that Rust is able to provide. So here's the case study of bundling Vue core with Rolldown. In Vue 3.2, our build setup was mostly JavaScript. We were using Rollup with the Rollup plugin TypeScript, with Terser, which is also a minifier written in JavaScript. And we're using API extractor for DTS bundling. The build setup is also a bit inefficient because we're essentially running TSC for every package due to the way Rollup plugin TypeScript works. So ultimately, in Vue 3.2, a full build takes almost 2 minutes, which is, I still remember those days. That was painful, right? So in 3.5, I was like, I'm tired of this. I want to refactor things, make things faster. So we moved over the TypeScript transform to Rollup plugin ES build. As you can see, one of the signs here is we want to circumvent TSC itself as much as possible because it is the biggest bottleneck, right? So when we use ES build, it's a pure syntax level transform, which means we don't go through TypeScript itself. We just do direct syntax transform from TypeScript to JavaScript. We use SWC for minification, which is written in Rust, so it's much faster than Terser. And we also switched over to a plugin called Rollup plugin DTS for DTS bundling. So the result was really great. We trimmed the whole thing down to 8.5 seconds, which is already, almost 15 times better than the previous solution. But with Rolldown and Oxc transforms, right, when we replace Rollup with Rolldown, and we can also get rid of ES-Build plugin because Rolldown comes with TypeScript transforms built in, comes with minification built in, and for the DTS generation, we can also get rid of the TSC call because Oxc supports a transform called isolated declarations. This is a new feature in TS 5.5, I believe, which if you turn the flag on, it will require you to write a bit more explicit type annotations for all the exported methods, but the result of that is your source code can now be, your TypeScript source code can now be transformed into DTS files directly through a syntax transform without going through TypeScript itself. So Oxc is able to convert your TypeScript to DTS in under a few milliseconds. It can basically generate the DTS for you, whereas running TSC on the whole code base probably takes a few seconds by default. Right? So now the whole build pipeline is like 1.1 seconds, and we can make this even faster because in the future, Rolldown will support generating and bundling DTS if you opt into isolated declarations. So you can have one bundling pass that generates both the JavaScript bundle and the bundled TypeScript definitions for your TypeScript projects. Right? So we hope that will give you a really easy way to say, like, I want to build a TypeScript library, and you no longer need to think about setting up complex tooling to do all the stuff. You just go down and everything just, you get the DTS, you get the JS, and you're good to go. Okay, so that's what we built so far, and what's next? So regarding the Vite architecture, right, this is how Vite looks right now. We have a pretty chunky JavaScript core. Then we rely on a bunch of third-party dependencies for handling some of the heavy lifting of the parsing, transforming, and bundling tasks. This is what the current Rolldown Vite looks like, right? We essentially replace these third-party, replace the previous third-party dependencies with Rolldown and Oxc. So now it's a vertical stack. We control everything. Everything can be sort of customized and tailored to the specific needs of Vite to be made more efficient. There will be less inconsistency. But a lot of the logic that still lives in Vue, still lives in the JavaScript core side of Vite. We do hope to move a bit more of them. Like I said, the eligibility of moving over to Rust is it needs to be a pretty well-defined task that doesn't change often. So one important thing we do want to do is that the module runner in Vite, this is an internal concept, but it's also what we use. For example, when you use Nuxt, it uses Vite's SSR transform thing to essentially run your code in Node.js for server-side rendering. It is also what powers Vitest. When you use Vitest to run your unit tests, Vitest uses Vite's internal SSR transform to make the whole TypeScript code base just work in Node.js. Right? So that part, we also plan to port to Rust. So that will make your full-stack apps run faster in development. That will make your unit tests run faster in Vitest. And we also want to introduce a full bundled mode for Vite, which means you can opt in to use a single JavaScript bundle during development, no longer over unbundled ESM. So this will solve the performance issue if you have a really, really, really large app and you still want to use Vite to load it over. When you use the dev server, the page will now load instantly instead of having to wait for the thousands of requests to come over HTTP. And so the full bundle mode is currently in a proof of concept stage. But we're seeing very promising numbers. Again, our goal is to essentially make Rolldown Power Vite the best possible dev tool in all categories. For development, for production bundling, for all the advanced features, including chunk splitting and module federation, we want to give Vite users the best possible option to the best possible performance, the best possible feature set, and maximum compatibility with what you're using today. Thank you. So that's it.
All right, thanks, Evan. That was amazing. We've got a handful of, we've got a few minutes left. If there are any questions out there in the audience, anybody, just raise your hand. We'll bring a mic over to you. If not, I'll start. I have a handful.
Sure.
First of all, I think it's absolutely amazing that we look at Vue, and then I think sometimes the perception is it's this great, small, intimate community. But what you've shown here is that there's just an expanding and expansive number of tools around it. And I think that's very cool, but I'm just gonna start very broadly and ask you, two-part question here. What's been the most fun part of working on Vue and all of the related projects, but also what's been the most challenging part?
Yeah, the most fun part is every time we have a new idea and work on something that's brand new without any sort of backwards compatibility concerns. In fact, like if you think about how I started Vue, how I started Vite, it's most commonly when I'm bored with what I call the mainstream task, and then I was like, I need to change my mind and just work on something different, and that kind of ended up turning into a bigger project than I anticipated. Right? So Vue started the same way, Vite started the same way, and in a way, when we started thinking about Rolldown, it's also kind of like I've thought about building a bundler for Vite for quite some time, but this one started because I got the chance to talk to a few folks who've had experience building this, who are now part of the Voice0 company. They had previously been working at ByteDance on RSPack. So when we talk, we're like, well, we need this kind of stuff for Vite. And turns out, before working on RSPack, they also had an experimental project trying to port Rollup over to Rust. And it was called Rolldown. Yeah. So I was like, we need Rolldown. We need you guys to work on it. So that's how it got started. I think it's always exciting when you have a new project. The most challenging part is when you try to bring about relatively big changes to a really established part of the framework. For example, when we introduced the composition API, when we introduced the breaking changes in Vue 3, a lot of them we had to like go through very lengthy RFC discussions. There will be pushbacks. There will be some people who are like, like composition API sucks. I don't want to use it. Yeah, so sometimes it's really hard to make everyone happy once you have a large enough audience. So it's kind of important for us to sort of cut through the noise and just, sometimes you got to trust our guts, like say, we believe this is better for the larger percentage of the users, and we just have to do it. Some of those decisions are not really fun, but we kind of do it because we have a responsibility to keep Vue relevant and keep, making people more efficient.
So deciding what you're going to support from a legacy perspective, it's part gut, part probably like the capacity that you have to continue to support an expanding feature set. Yep. All right, anybody else out there? We've got one.
Hi. So I have this is again a two-part question. So could you talk a little bit more of your learnings on the route to monetization of open source projects? Like when you start off Vue as a side gig, as you explained, and then sometime down the line you realize, hey, I can actually make a living out of this. I can quit my full-time job and do this full-time. So what was that like? And now this whole journey you went through, and now you're going for Voice0, that's VC backed. Now I imagine that to be quite a pressure on ROI since there is VCs involved. So what do you think how that journey would be different? Would the speed be different? The challenges? Will you be able to support Vue ecosystem parallelly, and how do you see that? That's my question.
Yeah, that's a really good question. So yes, the two parts are really different. When I started working full-time on Vue, it was partly because I noticed that my excitement, passion, mostly is like diverted towards Vue. Like I was getting less and less interested in my day job and more interested in just working full-time on Vue. So for me, when I quit to work on Vue full-time, I was, giving up a pretty comfortable job in return for a lot of uncertainty. That's taking quite a bit of risk. But for me, the biggest reason was being able to work on something I am super passionate about is a big quality of life improvement over to being locked into something I no longer want to do just for the money, right? But that really depends on your situation and what kind of person you are. For me at that time, it was I had some savings. I probably only have $3,000 a month from Patreon at the time I started doing it full time. but I was able to grow it steadily over time. So I think by the end of 2017, I was already making more than I did at my previous job. And in a way, Vue is kind of an outlier in terms of financial sustainability for independent open source projects. Because we grew at a pretty good during a pretty good time where, Vue kind of filled the needs of the community and we got a lot of exposure. So the exposure converted into sponsor interest. And we, as a framework, interact with users daily. So a lot of the sponsors are, specifically looking for the exposure to the Vue audience. In comparison, we've seen projects like Babel, for example. I personally know the Henry Drew, who was the lead maintainer of Babel for quite a long time. He no longer works on Babel now, but he was essentially the one who took over Babel when the original author, Sebastian McKenzie, kind of just left the project. Henry took over it and tried to make it sustainable, but it was actually very challenging because I talked to him a few times because Babel was sitting at a more, tooling infrastructure layer. People don't interact with Babel very often. Like once you set it up, you don't need to read the docs anymore, right? It kind of just sits under the tool chain, buried in the dependencies. So they struggled with funding, but Vue as a framework, we set a different layer. We have a lot more exposure to the end developers, so we somehow managed to make the sponsorship model work. So in a way, growing independent open source projects into sustainable ones is very case dependent. Like it depends on what kind of projects you have. It depends on your growth trajectory. It depends on, sometimes it does require you to be somewhat good and willing to talk to sponsors and solicit sponsors. I personally think I am a bit of I'm quite lazy on that aspect. Like I don't actually actively go out to solicit sponsors. So luckily we still have some sponsors willing to just come to us. And we have a lot of partners like Vue School, Vue Mastery, who just came to us and say, hey, we're making these paid courses or paid content, and we'd like to share a cut of the revenue with Vue. So that's really nice to have as well. So I think a lot of it is also trusting people and building these kind of partnerships with people who are sort of building on top of the Vue ecosystem. So as for Voice0, it is indeed a very different sort of endeavor because now it's VC-backed. And one important thing when we started thinking about looking for funding idea is, the biggest important criteria is I guess it's a little bit different because for a lot of people they think looking for VC funding is you're begging for 100 VCs and anyone who'd give you money, you'd just take it, right? For us, the situation is a bit different. For me, my criteria is we only want to look for a VC partner who understands open source, who trusts in open source, who want to actually see the open source side of it succeed, and then allow us to sort of give us the freedom and flexibility to explore a reasonable business model on top of it. Which is to say, people may have the impression, under the impression that if you take VC money, you'll be pushed by VCs to say, hey, you need to start making money now, right? It's a little bit different in our case, whereas our partner at Excel is a lot more lenient on the idea. I was pretty upfront. I'm for the first 2 years, we're just gonna focus on open source. Don't expect us to be making a ton of money out of the gate, right? And they're okay with it, and they support that. So I think that's really important. And also, the percentage of the stake these companies take, the term, how does the term sheet actually work? How much control they have? For example, we currently don't have any investors on the board, so I retain full control over the direction of the company, which means as of now, literally we're not under any sort of pressure to sort of say turn the project into money-making machines or anything like that. Eventually, we do have plans for business models, right? But the important thing is we want to find the business model in a way that doesn't compromise the integrity of the open source efforts that we're working on.
All right, and we can squeeze one more in. How about up here in the front?
Hi. Are there any notable improvements in tree shaking for Rolldown or OXC?
Yeah, so I mean, Rollup is already pretty good at tree shaking, but we do have an internal comparison document that essentially looks over a lot of the more advanced things. For example, we just recently shipped dynamic tree shaking for dynamic imports, which I'm not sure if Rollup does that. You know, like for example, if you have dynamic import to another module and you only use one export from that imported module, we're able to shake off the others. So overall, our goal for every category of feature comparison you can think of, you know, tree shaking, bundle size, you know, module interop, we all have very comprehensive comparisons with all other mainstream bundlers. And we try to be, you know, the best one.
Thanks.
All right, thank you all. One more round of applause for Evan Yu.
Thank you.